Hello everyone, this is the first lesson recording for IM2, January 14th, 2021. You started off by doing two warm-up problems where you're supposed to factor completely 3x squared minus 6x minus 45 and 54x to the power of 4 minus 132x to the power of 3 plus 48x squared. Okay, these are the last two factoring problems that we'll be solving before your quiz. So make sure you do them. A hint to get you started is always factor out GCF first. Look for GCF to factor out. That's going to make your life a whole lot easier. When you have your answers, I'm going to ask you to enter it in private chat. As far as the quiz number one goes, it's going to be in the last 15 minutes of the class. If you were absent for the quiz, then you need to contact me as soon as possible so that you can make the quiz up. All right, so let's finally talk about some factoring strategies, all the methods that we've done so far. Okay, that's the factoring out GCF. When A is equal to 1, we use guess and check for factoring. And then we also learned about area model and grouping method. And then finally, difference of square and perfect square trinomial. Well, those are many different strategies, right? How do you know which one to use? Well, which is the easiest? Okay, that should definitely be coming into a factor. Well, there you go, factor. So let's always look for GCF first. So for example, when you see 2x to the power of 3 plus 6x squared minus 8x, at first glance you might think, oh, I do not know how to factor this because I do not know how to factor when you have a higher degree than 2. When you have x to the power of 3, that's a different kind of factoring altogether. However, once you take out the GCF, okay, so first thing you're looking for is, I see the numbers 2, 6, and 8. Oh, they're all even. That means I know I can take out at least 2. What about the variable? I have x cubed, x squared, and x. That means for each of the three terms, x is a common factor too. So I take out 2x, and then finally in the parentheses, I am left with x squared plus 3x minus 4. And what's inside the parentheses? I know how to factor that. Okay, it's just a simple quadratic with a is equal to 1. So again, always look for GCF to factor out. Even if it's just numbers, by factoring out numbers, you're going to be dealing with smaller numbers to factorize. And if you have a smaller number, that means you have fewer factoring options. So it's going to make your life a whole lot easier. So always look for GCF first. That's for any pattern, any polynomial, you do that. Okay, and then the second level is the quick patterns that we've learned. Okay, so we have learned three different quick patterns. When a is equal to 1, that means there's no coefficient in front of the x squared. The coefficient is just 1. That's a simple guess and check factoring, right? Where you're looking for what are the two numbers that multiply to 4, 1 and 4, but add to 5. That's 1 and 4. And you can just simply do that. You start off with putting the x first, and then you look for those numbers. We also learned the difference of squares so that you can immediately recognize the pattern and then split that into the difference of square template. Okay, so the pattern is it's two term, perfect square on the first term and perfect square on the last term, and the operation between first and the last term is a subtraction. And the pattern is that square root of the first term goes 6x here, 6x here. Square root of the last term, 5, 5 here. Okay, and then one's going to be negative, one's going to be positive. What about perfect square trinomial? That's where you have three terms, but the first term is a perfect square and the last term is a perfect square. And the middle term, and they're both positive, okay? And the middle term is sum double of square root of the first term and multiply by square root of the last term. So that's going to be square root of 9x squared is 3x, multiplied by square root of 16 is 4. 3x times 4 is 12x, and double that is 24x, and that's what we have. So we know how to put that into perfect square trinomial pattern, and that's the answer. Okay, so those three, you should be looking for the pattern. And then finally, when um, when your quadratic does not fall into any of the three, that means you just need to go do the old-fashioned way. Okay, so you can choose either the area model or the grouping method, but whichever method you choose, you should be very good at it. Okay, just choose one and become very fluent with it without making any error. And finally, as always, regardless of which method that you use, you should always multiply back to check your final answer to make sure that when you multiply it back, you get back to the original quadratic expression. So that's the way to make sure that you're doing things correctly. Okay, so as part of your warm up, you were asked to factor this. Okay, and I gave you the hint that you should look for GCF. Well, when you're looking for GCF, first thing you should do is look at all the numbers 3, 6, and 45. Is there a number that um, is divisible by all three terms? And the answer is yes, it's 3, right? 3 is, while it's looking at the variable, I see x squared here, x here, but no x here. So that means I can't take out any x's, but I can take out 3. What 3 times what is 3x squared? That's just going to be left with 3, just x squared. 3 times what is negative 6x? That's going to be negative 2x. And then 3 times what is negative 45? That's going to be negative 15. Okay, now what's left inside the parentheses is much, much simpler for us to factor because a, the coefficient in front of x squared is 1. Okay, so that means I am just going to put my template with x at the front, 2 x's at the front. Okay, so now I am looking for a number that it multiplies to negative 15, but that adds to negative 2. The two numbers that multiply to negative 15. Well, what are the factors of 15? Negative 15. It could be 1 and 15, or it could be 3 and 5, right? But since one's going to be positive and one's going to be negative, let me do that right here. Okay. Okay, that means one's going to be positive, one's going to be negative, or negative positive. We don't know which one yet. So since we are adding these positive and negative, two positive and negative numbers with opposite side, that means we're looking for the difference of the two numbers when we are just dealing with the signs to be negative 2. Okay, so if I have 1 and 15, the difference between the two number is 14. That's not going to be negative. That's not going to be 2. And while as 5 and 3 is going to give me 2. So that's my combination. Except I want negative 2. That means I need the bigger number to be negative. So it's going to be negative 5 and plus 3. Okay, so this is my factored form. Now again, as usual, you should always multiply back using either FOIL or area model. Okay, so FOIL says first with first, that's going to be x squared. Outside, x times positive 3 is going to be plus 3x. Negative 5 times x is going to be negative 5x. And then L is the last with last. Negative 5 times 3 is negative 15. After combining two like terms, I am left with x squared minus 2x minus 15. Okay, Now you're saying, oh, but that's not our original expression, is it? Okay, but we forgot the 3 here. Okay, that's very important. Okay, just because you factored this, you've just factored this, you have not factored this. So this is the complete factored form. Okay, if you give me just x minus 5, x plus 3, that is not equivalent to the original expression. So you do need to give me the 3. Okay, so then you say, okay, so I do need to multiply this by 3, and you are left with 3x squared minus 6x minus 45, and we're done. And it checks out. Okay, next problem was 54x to the power of 4 minus 132x cubed plus 48x squared. Okay, again, we look for GCF first. And what do you do? What do you get when you look for GCF? Looking at the numbers first, I know that 6 is divisible by all 3 terms. Okay, so and then looking at the variable, I see x squared here, x to the power of 3. That means that's x squared times another x, and x to the power of 4 is x squared times x squared. So once I've taken out 6x squared is another factor. Then you're left with 6x squared times what is 54x to the power of 4. That's going to be 9x squared. 6x squared times what is negative 132x to the power of 3. That's negative 22x. And then 6x squared times what is 48x squared. That's going to be 8. Okay. Now from here, we are going to try to factor 9x squared minus 22x plus 8. Okay, so the first thing I need to do is do my diamond for 9x squared minus 22x plus 8. Again, we're just factoring this. And at the end, we're going to put the 6x squared back. Okay, so then multiply 9x squared times 8 is 72x squared, or you could just put 72 here if you like. And we're looking for the sum to be negative 22. And we look for the two numbers that multiply to 72, but that add to negative 22, and that's going to be negative 4 and negative 18. You can use the area model by filling in the first term, 9x squared goes here, and the last term goes in here, and then 4x and negative 18x goes in the other two missing boxes. And then you factor out the columns and the rows to figure out the two factors. Okay, if I was to use the grouping method, that will be 9x squared minus 4x minus 18x plus 8. I just split the negative 22x as negative 4x and minus 18x or minus 18x. Okay, so then you look for GCF here. Okay, so as far as 9 and 4 goes, there are no numbers I can factor out, but as for the variables, I can factor out x, which leaves me with 9x minus 4. And for the second part, I can factor out, they're both even. The only numbers I can factor out are 2. That leaves me with negative 9x minus, oh, plus, um, plus 4, but that's not what I want. So I'm going to change this to negative 2. I'm going to factor out negative 2, and that leaves me with 9x minus 4. And 9x minus 4, 9x minus 4 is common to both. So I take that out as my factor, and you're left with x here minus 2. And that's what I have here. But remember, I have taken out 6x squared, so I need to put that back. And that's my final factored form. Okay? And I'll continue with the rest of the lesson in the next lesson recording.